Thank you for joining us. Today we're here with James Wright, who is an assistant professor at the University of Alberta and a fellow at the Alberta Machine Intelligence Institute. James is an expert in machine learning when used for predicting human strategic behavior. Thanks for joining us today, James.
Thanks for inviting me.
James, could you please introduce yourself and tell us a little bit about your research interests?
Sure. So I think a lot about the interactions of multiple agents and the special issues that come up when there's more than one agent who have to cooperate or compete. And I especially think about those situations when some of the agents or all of the agents are people, so actual human people. Because of that, I think a lot about limited rationality or bounded rationality, as we call it. What does that even mean? So that turns out to be a difficult thing to define. And so one of my interests is, first of all, defining how you should expect a boundedly rational agent to behave. And second of all, modeling how people actually do behave. So understanding and being able to predict human behavior in these multiple agent interactions.
So that's interesting. So it seems like, in many times we try to treat AI agents as though they were perfectly rational. But of course, nothing that we do in the world is perfectly rational. So your work kind of works to deal with a little bit of that messiness of the real world. Is that correct?
Exactly. So a very common computer science approach is to say, how can I get as close to optimal as possible? In the real world, perfectly optimal behavior is just an unattainable goal. It's not possible. And that's all the more so true for people, of course. And it turns out that when you try to model how people behave, it's not just optimal, but maybe not quite. It's not just that we try to be optimal, but it's a little bit different. Instead, it can wind up being quite qualitatively different, again, especially in multi-agent interactions. And so I'm interested in these sort of predictable and qualitative differences that arise.
Can you tell us a little bit about some of the work that you're working on right now?
One project that I'm particularly excited about is applying behavioral game theory to econometrics. So I'll tell you what I mean by all of those. So behavioral game theory is the study of interacting humans in environments that we would normally study with game theory. So game theory is a mathematical framework that lets you model how perfectly rational agents interact with each other. Behavioral game theory instead models how human agents interact with each other. What econometrics does is it says, I want to look at the behavior of people. I want to look at what people are doing, and from that, try to infer something about their preferences. So frequently you'll want to infer how much do people like a certain object, how much do they like a certain product, how important are certain aspects of a service to them. But the standard econometric approach relies on the assumption that everybody is behaving optimally. It says, suppose we're all behaving optimally, what then can I infer from your behavior? So in this project, what we're going to do is we're going to take behavioral models, so models that account for the fact that people are imperfect, and try to do the same thing. Can I back out some sort of information about people's preferences based on how they're acting without having to assume that they're perfectly rational?
I can already see some of the areas where this might be able to be applied, but maybe you could speak more about, how this work that you're doing could be used to improve, human decision making, for example.
Well, one thing that it's very useful for actually is platform design. So if I have a couple of different ways that I want to design my platform, but I'm not too sure about how people will use it, then understanding how people will react to the different options that are available to them, depending on their values, is something that's going to help me design the platform to be as useful as possible to the people who use it. That's almost the main thing that I'm interested in with this project.
So it's really about, taking into account all the myriad ways that people will use a system, for its intended purposes, and maybe use a system differently than what its designers originally intended.
Exactly, and trying to reduce the discrepancy between those two things. So trying to reduce the discrepancy between how people use a system and how it was intended to be used. So if I can spot that people are going to, or if I can predict that people are going to use a system in a way that's very different from what I was hoping for, then either that's because I'm providing the wrong service in the first place, or it's because I'm presenting it in the wrong way. And in either case, I should change the way that my system is set up so that it can provide the most value.
That's fascinating. So this could really help an organization, for example, to figure out how to develop the system, better the first time around, and not have to make further changes or updates or completely revamp the system in the future.
Exactly. It's about being able to predict these kinds of unintended consequences without having to go through a bunch of really costly iteration.
Well, that's wonderful. That's really exciting research, James. Thanks very much for sharing that with us today.
Thank you. It was my pleasure.